Sweet. Did you have any questions on the homework?
Pretty easy, actually.
Yeah, that's what we thought.
I feel like it was just kind of a refresher on probability. Well, then I'm fine. If you didn't have any questions, we didn't either to start.
On the
Really?
quiz.
Yeah, I'm going to pull it up. Okay. Sweet. The quiz. Okay. So, okay. Okay. So do you see the table?
Yeah, mine's still loading.
Oh, okay. So I'll wait. I'm gonna pull up the book as well, because it's always helpful.
Yeah. Very true.
Okay.
So it's asking about the probability distribution.
I pull up the book.
Okay.
Okay, there we go. Let me see if I can find it in the book.
Okay.
Unless you have an idea.
No, let me
Okay.
get it.
Okay, so it's part 2.3, rules of probability in the book. Just said, there are 3 short rules that probability distribution must follow.
Oh, okay.
Okay, so it's that question. So we just need to see if it fits, if that chart fits what the 3 rules are. So X is a number between 0 and 1. And if you list all the outcomes of an experiment, the probability that one of these outcomes will occur is 1. In other words, the sum of the probabilities of all the possible outcomes of any experiment is 1.
Okay, so it's over 1.
So is it, then I would say no. So false then, right?
Uh-huh.
That's what I'd say, yeah.
What is the probability that a randomly selected person in the United States has type O blood? Round to the nearest decimal, please. 4. So, let me see. What did you get?
Well, because usually you find that when it equals to 1, and that's what you go off of.
Mm-hmm.
So are you guys just still basing it off of 1? Or, like...
I would assume so, yeah.
Are you just putting them all up?
Let's see, because there's 4 different types of blood, right?
Mm-hmm.
I mean, if these are like the example problems,
Yeah.
let's see.
So if we look at the table,
Like, what are the chances that they have type O blood?
if we look at the note above,
Yeah, it's summarized the following table 1. So yeah, it is 1.
Okay.
round 2 decimal places.
So what did you get?
0.55.
And how did you do that one?
Well, are we like assuming that the one?
What was that?
Are we assuming that all the data equals 1 with the proportion?
Yeah, it says that in like the question. You go.
Okay.
It said like summarize the following table. Maybe not.
Well, because it would be 4 different blood types, and if the proportion's 0.45, then we'd have, put it over 4.
Oh, okay.
Yeah, so I got 0.11 just because I just put
Okay, yeah.
0.45 over 4.
Yeah.
And then it's going to ask the exact same thing for type O blood.
But
So,
just the other way.
wait.
For those that, so the next question is those that do not have.
So it would be those 3.
So would we add them up and then divide them by 4?
Do
Yeah,
not
I think.
O blood. Hold on, how did I do it here? Or, since there's 4 options, would you go 3 over 4? Because I only think that because there's 3 options other than type O blood.
True.
And you would put that over 4 and you'd get 0.75. That's just my assumption. Well, that's how we did it, like in the individual prep assignment. I'm gonna try it, and if it's not right, then I might try adding them all up.
Okay.
We can go to 6. Let's see. Carolyn and her colleagues conducted a study in which dogs were trained to detect bladder cancer when dogs were trained to lie down next to a specimen delivered from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification. 7 bowls containing urine were lined up in random order. 6 of the samples from patients did not have bladder cancer. 1 of the samples from the person identified as a bladder cancer patient. If the dogs guess at random, what's the probability that they will correctly identify the dish with the specimen from the cancer patient? So would it be, so there are 7 people total.
Mm-hmm.
And
Would you put 1 over 7?
Yeah.
Which is,
0.14.
yeah.
so it wants us to round at least 3 decimal places.
It would be 143 then.
Yeah.
So would we put, how are you putting in 0.
143, yeah.
Okay. Okay, in a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There is little evidence that dogs can detect bladder cancer. There were 0.4.
Yeah, I got 0.4.
I mean, almost half. They're almost right most of the time.
I would say that's
That
strong
almost
enough.
means like half the patients had it, and so it could be random guess. I would say there's evidence then. What would you say?
I don't know, because it's not like strong evidence that they're doing that.
Right.
But
No,
it's still,
because still
yeah, I don't know.
people had it. Then I would
I don't know.
say no then, because the evidence isn't strong. That's a good point. Let's go with no. Okay. M&Ms are small chocolate candies. The M&Ms on the website previously indicated that in the U.S. the distribution of the colors was given in the following table. If you reach into the bag of M&Ms, what's the probability of drawing a red colored candy? This is like, do you remember doing this?
Yeah, in like grade
elementary school, you have to eat the M&Ms.
Yeah.
It never ends.
So
Okay.
red.
So 0.13 divided by
6 options.
6 options, which is
0.021.
so round
How
to
many decimal?
2 decimal places. So
So
0.2, 0.02. Did you get that too?
No.
What did you get?
See, well, because I watched the video and he had us like he had an example like this, and first we found what the green was worth,
Oh, okay.
and then we. Oh wait. Never mind. You guys are right.
Okay, it's like, because do we need to know the green? What's the probability that?
green, yeah.
No.
And I would say we need to, because the next question asks us, what's the probability that candy is green?
We got like, yeah.
It's a 1 out of 6 chance that it's green.
Because I also probability is a little more complicated than just finding it.
Yeah.
Right? Like,
Yeah, so I think we do need to find what green is.
so Jensen, what did the video, as far as looking at the green, what do you remember on that?
Well, because one of the rules is all of the data will equal up to 1
Yeah.
at all, and then do 1 minus what it's all added, and that's what the green is.
Okay, well, let's find that then.
I was so close, huh? I messed up my decimal.
3 plus 0.24 plus.
So I've got 6.16.
Do that. It'd be 1 minus.
So then just minus 1. So green
it's
would
going to be
be
positive. It's going to be 0.16. Is that what you got?
Yeah.
So now we're
Yeah,
able to do the problem, right?
so now it's asking about if it's not green.
Mhm.
I think you need to add a 2. Or wait, how many decimal places? 2? Okay. So
So wouldn't that just be the number of them all added up? So 0.84.
Yeah, which was
0.84.
0.84. That's what all the ones are added up minus the green.
Mhm.
We don't need to divide it. I guess not, because yeah.
Use the following information to answer the next 3 questions. Half of the observations are less than or equal to what number?
Authorizations are less.
No, I'm not quite sure how to do this one.
Look in the book.
Yeah, that's what I'm scrolling through. Talking about stuff we have done before. The mean, standard deviation,
Mhm.
less or equal to what?
Ew. Are less than or equal to what? Oh, would that just be the median?
I would think so then.
Mm-hmm.
which is what, 24.3? But then the next one is
No, the median's just 24.
Yeah, just 24.
oh,
The top 25% would be the upper quartile,
isn't
right?
that quartile 1, which is 22?
Uh-huh.
And then last question, which of the following statements is not one of the 3 rules of probability? Okay, so it's not the second option because probability is a number between 0 and 1. And then let's see, the book says the sum of the probability in any probability is 1, and the probability that an outcome will not occur is 1 minus the probability that it will
Yeah,
occur.
that's on there.
Okay.
Yeah, so I think it's the positive and negative one.
Yeah, I would say so. Okay.
Do you guys want me to submit it first?
I can do it if you want me to.
Do you want me to do it?
Chris, yeah. Okay, it's just loading.
Okay, we missed
Mhm.
6.
Dang. Okay.
So
Which ones did we miss?
we missed
Number
the
3?
first 3.
The first 3, like all of
Yep.
them?
Yep.
Yeah, we sure did. Okay.
Number 3.
Yeah.
Number 3 is true.
Trying to see why.
That was confusing to me. That's weird.
Well, I guess because they do all equal 1.
Yeah, they do. I don't know why my calculator is being weird.
So, like, they follow all the rules.
That's true.
Yeah,
If
you're
we
right.
had gone through that, we would have been able to figure it out. Okay. And number 4 is not point. That's weird. I don't know, like, what the answer would be then.
4.
Yeah. And didn't you have another way to do the problem?
Yeah. What? Yeah.
Let's try it that way and see maybe if that's it.
Okay. Let's type O blood. So I think you would just do 0.45
Okay.
blood.
And then what would you do after that?
That's well, because I don't know. That's a weird.
What'd you say? What do you do, like, after you put in 0.45?
I just did 1 minus 0.45. But then that would be the being O.
Let's look. I'm not sure. Because we missed those 2, which makes sense because we're, like, missing a concept.
Yeah.
What's another one?
Yeah. Also probably a bit of random.
We missed 4 and 5. We also missed 7.
7? So it'd be strong evidence then. I was torn because they detected almost half, which I guess would be proven as strong evidence, but at the same time there was only,
What if the proportions or the probability? Because if you look at, like, we missed number 8, we got number 9 and number 10 right. So that means we can calculate when things are not as successful.
Wait, so we missed number 10.
No, we got number 9 right.
So number 8's wrong.
Number 8's wrong. 8 wouldn't be 0.13, right? Or would it?
Why would it
Number
be?
8.
Would you use proportions?
I don't think so, because that's not what we do for here.
But
For A,
yeah, we divide it by 1. Oh, well,
for number 8, you'd have to you'd have to add in the green and then
So do we need to like add them all together and then take the?
yeah, or you just do because it all adds up to 1. So the probability of drawing that candy is just
Okay. Sorry,
I
sorry,
put point.
Oh, thanks, man. Appreciate it.
that's embarrassing. I'm sorry. I guess I'm lost. I don't really know what it would be then. So we need to add green into the like calculation then.
Mhm.
Okay. So that would make it 0.1.
9.
What was that? Sorry, you're cutting in and out.
Did we get number 9 wrong or did we get it right?
No, we got number 9 and 10 right.
Yeah, we're just missing 8.
Okay.
Like we're on the right track.
Two plain bag of M&Ms.
I just like don't get. Would we add all these numbers and then divide by 6?
Well, the numbers would be 1.
True.
So it'd technically be 1
Well-
6.
Well, where did
Right.
you guys read who divided stuff? Dividing how many there were. It just talked about like subtracting the amounts.
True.
So I don't like is that in the textbook?
I mean, like for the 2 example problems, that's how you found them.
On the preparation?
Mm-hmm.
Because that's not what I did. Oh, let me see.
I mean, like I could pull it up, but like that's how I found it, and my answer was right. Let me look really quick.
Oh, okay. Yeah. Yeah, I got those too. I got them right.
Okay, look, hold on. It's like I guess I'm unsure how to find those ones then. Yeah, I did them exactly how like the things said to do it.
Okay.
So essentially, if we just look at the problem as we have 6 options of colors, right? So that's a 1 in 6 chance that if we reach into the bag, we pull out a green. Right?
What other ones did we miss?
That was, and then we missed number 12. Let me make sure we're looking at the right quartile.
So it could have been the minimum quartiles. I'm really confused how that isn't it then. Like, I still don't know how to find number 8.
I think number 8 would be, if we had a 1 in 6 chance, it'd be 0.12 or 0.13.
Yeah, I don't know if it's that easy, you know?
Yeah.
Hmm. Oh, because it wouldn't make sense because it's like the proportion, like that's the amount.
Yeah, that's why we gotta
What's in?
look at the proportions.
Yeah. Hmm.
Okay, the probability of drawing a red colored candy. I
It'd
seriously
be a 1 in 6 chance.
no.
Because there's only 6 options.
Yeah, I know, but I feel like if it was that easy, then I can try it that way. But what number did you get from that? Yeah, there's no way. 'Cause that's
167.
okay. I don't know. I might wait for a minute and work on. Did we ever finish?
Yeah.
No, we never finished 4. I'll leave that one blank too. We missed number 12. Based on the information, the
12.
25th percentile, like what students scored above the 25th percentile.
Oh.
But we just looked it up, and quartile 1 is the 25th percentile.
It's asking how many scored.
Above it. So would we add
The 25th percentile.
so would we add the other ones then and then do everything out of quartile 1?
Yeah, but would that be like, yeah, would that be quartile 3 and the maximum?
I would say so, yeah.
Or do we add them, or is it just the maximum number?
We need everything because it's saying what students scored above, the top 20% scored above what number. Okay, so the 25th percentile scored a 22. Means they scored above everything below 22. Does that make sense?
Yeah.
So it'd be 21. Do you see like my thought process?
Yeah. The top 25% of students scored above what number?
Because the top 25 scored a 22.
Right, so
I'm almost wondering, would it be 14? Because that's what like the lowest scored.
Mm.
It's like the quartile underneath them scored 14. Because the next quartile is the third, and that's like 50%.
Yes, I think it would be 14.
Okay, let's try it. I mean, if not, we can still come back. Now we're back at those other ones. number 8 and number 4.
Okay.
I mean, 4 and 5. Because once we figure out how to do 4, we'll know how to do 5.
Last time. Hold on. Mm,
I don't even know how we'd find it then. So I feel like if we figure out that one, we'll know how to do number 8.
Mhm.
You know?
Yeah. Yeah. Mm,
I'm gonna try to look in the book for like an example, but
yeah, me too.
I can't find any.
When I could watch the video thing again.
Yeah, we could do that. Hmm. Let's see. Because the book is talking about finding the mean. We don't need to find that, do we?
I don't think so.
Hmm. What do you think?
I'm looking in the book.
Would it be like the same way we did 9 and 10?
That's what I was thinking, because if we got 9 and 10 right, it shouldn't be any different.
But we have all the numbers. That's the difference.
Mhm.
I have no idea. The difference between 9 and 10 is we have all the numbers.
Right, but we found green, and that's how we could start solve 10.
Yeah.
So
But
if we added all of the proportions,
should be 1.
but minus the without type O, then we should have the answer to.
So try that.
So yeah, it'd be 0.55% without type O blood. Would that mean with type O blood would just be the 45% or the 0.45? That seems too easy.
I mean, we can try it. Like, I don't have a better idea. I doubt it. I can try it. I think I have all the updated answers. Oh, number 8.
Try to just put 0.13.
I just don't think that's it.
That seems way too easy.
That's what I'm saying.
But if we got 9 and 10 right, that's exactly what we did on them.
Mhm.
Yeah, I'll try it. Okay.
Oh, we missed one.
We only missed one now. Now we only missed number. We only missed number 12. So we were right. It was literally that obvious the whole time.
12 is going to kill us, though.
That's so annoying. We literally sat here and convinced ourselves that that was too easy and that was the answer.
Oh, jeez.
Yeah.
That was for 8.
That's math for you.
Nobody finds just anyway. Okay.
Okay, I'm gonna try the quiz again.
Right?
Seriously.
Seriously. 14 out of 15 sounds
I'm a
pretty good.
grade freak though, so
25%.
catch me up.
Yeah. So, hey, and Jensen, help me make sure I'm right too. It goes, well, past 1 and 2, then number 3 is true. 4 is
Mhm.
0.45. 0.55. 0.143.
Strong evidence.
Strong evidence.
Wait, can you go back to 4 and 5?
Yeah. 4 is 0.45 and 5 is
Okay.
0.55.
Oh, gotcha. Okay, so it was just the.
It literally
Yeah, it
was
was
like
that
right in front of our
easy.
faces the whole time.
Oh, jeez. Okay.
Yep. God.
So
You're
then
going
going on 8.
0.13.
0.16.
Okay.
10.84.
Okay. 11.
24.
12 we missed still.
12 we missed.
13.
And a positive and negative.
Okay, 12 we missed again. Okay, based on the information, the top 25% of the students scored above what number? Okay, so the top 25% scored a what?
22.
22. So they scored above what number?
Above 20.
For the maximum, so they scored above. I have no idea. What do you think?
I'm trying to think if we have our quartiles mixed up, because if you look at quartile 3, it says 27.
We'll look at the upper one. Look at the, because it said quartile 1. I might pull up my old homework on like the quartiles.
Yeah, that's just what I was doing.
Three.
3. Well,
So the max scored above 27. So would it be 27?
yeah, I would say. Jensen, do you want to try 27?
Not 27, 30. Would it be 35?
Well, that's the max.
I don't know. I mean,
So to be put in the upper 25%, you would need to score higher than.
so look, these all say 25%.
Yeah.
It could be any one of these.
Well, because I remember each one like 25%. So the maximum would be 25% away from quartile 3. So I think it would be 27.
Okay.
So go ahead and try that and see if we're in.
loading.
It's okay.
Another experience. I want to get down in these
Are you done?
Okay, yeah, so it's 27 is right for 12.
It was, so you got them all right, Nan. Or you should.
Hopefully. Guys, that was way too easy for us to miss it.
Dang. Okay, well, we're done then.
Okay, awesome. Jensen, thank you so much.
Okay, see ya.
Uh-huh.
Okay.
You.